Welcome to today's Explainer, where we're officially putting on our safety analyst hats to conduct a forensic audit of a collapsing military logistics network. Today we are looking at a fascinating, real-world case study in systemic failure, and we're going to focus strictly on the technical, mechanical, and logistical realities derived from recent aviation data.
So you might be wondering, why exactly are Russia's strategic bombers just falling out of the sky without even being shot at? Let's dive right into this systemic mystery and uncover how deep-rooted supply chain rot is bringing down irreplaceable supersonic aircraft. We're going to look past the battlefield today. Instead, we're focusing entirely on the maintenance base, the supply lines, and the corporate balance sheets to answer one absolutely crucial aviation safety question: what actually happens when a complex machine is starved of the infrastructure it needs to keep flying?
Here's our roadmap for this audit. We'll cover the anatomy of a crash, decades of structural fatigue, the logistical choke point, Aviaremont's maintenance meltdown, degrading strategic strike power, and finally, preventing future fleet failures.
Let's start with Part 1, Anatomy of a Crash, the June 2026 Svirsk Incident.
The facts of the June 15 Svirsk crash reveal a catastrophic, non-combat mechanical failure that forced the crew to completely abandon a multi-million-dollar asset. According to the source data, this Tu-22M3 bomber was just returning to Blaya Air Base from a routine unarmed training flight. Now, video footage from the ground actually showed the aircraft in a steep, nose-down dive, trailing fire from its aft engine compartment right before impacting a wooded area near the Angar River. Thankfully, they had enough altitude so all 4 crew members were able to safely eject. But look at this from a safety analyst perspective. A massive bomber simply falling from the sky on a routine flight, that is a massive, glaring red flag.
And here's the thing. The Svirsk crash is not an anomaly. It's actually the third fatal symptom of a repeating pattern in the extreme Siberian climate. All 3 of these crashes occurred in the Irkutsk region, which is home to the Belaya Air Base. So we're seeing a localized cluster of catastrophic technical malfunctions here. This points directly to systemic stress. These airframes are subjected to severe winter freezing and rapid thermal shifts, which just wreaks absolute havoc on hydraulic seals and structural welds over time.
Which brings us to Part 2, Decades of Structural Fatigue, Pushing 30-year-old Airframes to the Brink. Now, the Tu-22M3 was originally designed as a deep penetration and maritime strike bomber. It was meant to fly low and incredibly fast at speeds exceeding Mach 1.8, all while carrying a heavy payload. Doing that requires immense structural integrity, but these surviving airframes average over 30 years in age right now. Production ended entirely back in 1993. Think about the contrast here. When you push a 30-year-old, highly stressed airframe to maintain a high operational tempo, but you don't have proper factory support anymore, the metal simply begins to fail. Because the Tu-22M3's NK-25 engines haven't been manufactured since 1996, crews are essentially forced to use uncertified, fatigued turbine blades that eventually trigger a devastating mid-air fire. Our sources indicate that maintenance crews are relying heavily on recycled parts or uncertified field repairs. Under the immense physical loads of supersonic flight, these fatigued turbine blades can literally shatter inside the engine. This causes an uncommanded fire that severs adjacent hydraulic lines, leading to exactly the kind of uncontrollable nosedive we just witnessed in the Svirsk crash.
Moving on to Part 3, the logical choke point, grounded transports and stranded parts.
You see, when Russia lost access to Ukrainian aerospace manufacturing back in 2014, their Antonov heavy transport fleet lost its supply chain. That means those 3.4-ton bomber engines cannot physically reach Belaya Air Base anymore. A bomber base in remote Siberia relies entirely on heavy cargo planes to deliver massive components, like engines and landing gear. Without the Antonov design expertise and the spare parts that previously came from Ukraine, Russia's own transport fleet has basically become permanently grounded. And it's pretty simple math. You can't fix the bombers if you can't transport the parts to fix them.
This logistical choke point is deadly. The transport planes meant to deliver the bomber parts are literally breaking apart mid-air due to the exact same lack of maintenance. The December 2025 crash of an An-22 transport over Ivanovo during a post-repair test flight is incredibly telling here. It perfectly mirrors the safety crisis of the bomber fleet itself. Leaked documents confirm that out of the 368 An-series aircraft operated by Russia, 143 are permanently grounded because the Ministry of Industry and Trade admits there is zero domestic production of replacement parts for them.
Let's look at the business side of this in Part 4, Aviaremont's maintenance meltdown, the corporate collapse. Leaked internal documents reveal an immense funding shortfall just to begin addressing the transport repair backlog.
We're talking about $300 million. And the worst part, that capital isn't even scheduled to arrive until 2029. The state enterprise Aviaremont is the sole entity keeping these military fleets flying. But their own internal reports show that to even kick off a new program to fix the transport shortfall, they need cash they just don't have.
So the absolutely crucial takeaway here is that Russian officials are privately admitting their primary aviation repair facility is essentially insolvent. It's totally incapable of fulfilling its strategic mandate. The 308 ARZ facility in Ivanovo is the main repair hub for these critical transport planes, and these leaked memos state plainly that advance payments from government contracts have already been spent, they lack design documentation, and they are facing actual, literal bankruptcy.
And to top it all off, the guy in charge, Albert Bakamov, the Director General of Aviaremont, is an economist specializing in Japan with absolutely zero aviation experience. He's steering this collapsing maintenance empire. I mean, what could possibly go wrong, right? The documents note that he previously oversaw other defense enterprises that also faced acute financial difficulties under his tenure. When you have a highly technical, engineering-heavy logistics network overseen without technical expertise, safety protocols erode, and systemic failures like the ones we're seeing in Siberia become completely inevitable.
So what does this all add up to? Part 5. Degrading strategic strike power, the permanent attrition. Because these bombers went out of production in 1993, a 70% attrition rate from combat losses and mechanical crashes represents an irreplaceable permanent degradation of power. Various sources place the total remaining active airframes around 56. But some defense analysts estimate that when you factor in the destroyed, heavily damaged, or grounded aircraft that are just acting as parts donors, the truly operational, combat-ready number could be as low as 9 to 10 aircraft. Every single crash, whether it's from a missile or just a worn-out engine, permanently erodes the fleet.
To preserve this final handful of aging airframes, commanders are forced into highly predictable, incredibly restrictive flight profiles. The Tu-22M3 was explicitly designed to penetrate air defenses at low altitudes, but because the airframes are so severely worn out, and because they are just too valuable to lose at this point, they're now relegated to flying high and far away. They merely act as launch platforms for cruise missiles well within safe airspace. Their operational flexibility has been severely compromised by their own mechanical fragility.
Finally, Part 6. Preventing future fleet failures. Actionable safety recommendations.
Without implementing these 4 massive, incredibly expensive logistical overhauls, the forensic evidence practically guarantees that more bombers will inevitably fall from the sky. Let's run through them. They desperately need the modernized NK-32 engines to finally stop the thermal runaways. They absolutely must use advanced NDT, that's non-destructive testing like ultrasound and X-rays, to find metal fatigue before it snaps midair. They have to rebuild a heavy transport fleet from scratch to deliver parts. And they need modern 0-0 ejection seats. Those are seats that can safely deploy at 0 altitude and 0 speed, just to protect the crews when the planes fail right on the runway.
That is the ultimate question this audit leaves us with. As the maintenance backlog grows and irreplaceable bombers continue to burn, how long can a 20th century fleet really survive a 21st century war of attrition? I highly encourage you to reflect on what a collapsing supply chain actually means for the future of global air power. Because at the end of the day, when the parts stop moving, the planes stop flying. Thank you for joining me for this technical explainer. Keep questioning the systems around you, and I'll see you next time.